In this video, we are going to discuss about linear transformers, problem on linear transformers. So the given problem is solve for I1 and I2 using T equivalent circuit for a linear transformer. So this is a given circuit. So you can see this is how the transformer look like, and you have to think that I1 should always flow like this. Okay, in this manner only, I1 and I2. Okay, let me term this one as IB. Okay. Okay, for this one only, you can form the T circuit. So this one I have to replace it by replace like this. Okay. So this is your L1 and this is your L2. So what is L1 means? L1 is equal to J5. Okay, J5 minus of M. So here M values J3. Okay, so since both the current are incoming towards this, I can write it as J5 minus J3. So it is 2J. Okay, and in similar manner, I can write L2 as J6 minus M. That is J6 minus 3J. That is 3J. Okay. In similar way, I can write M as J3. So it is nothing but another L. So okay. So this is J3 and this is also J3. This one is 2J. Now I can draw this 12 and this is minus J4. Okay, this is 2J, 3J, 3J, and this one is 12. So this is your I1 and this is your I2. Okay, so this current is I1 plus I2. Okay, so I can, for the mesh 1, I can write it as 12 is equal to minus 2J I1 plus 3J I1 plus I2. So I can write it as JI1 plus 3J I2. So here 12. So this is your first equation. And for the second equation, 12I2 plus 3JI2 plus 3J I1 plus I2 is equal to 0. So this is 6J plus 12I2 plus 3J I1 is equal to 0. So if I divide both terms by 3, so 2J plus 4 I2 is equal to minus J I1. So what is I1 into J? I1 into J is minus of 2J plus 4 into I2. Okay. So this is your second equation. So substitute this. So 12 is equal to minus 2j plus 4i2 plus 3j I2. So that is equal to ji2 minus 4i2. So I2 is equal to 12 divided by j minus 4. So they have given the value as I2. Given this one as IP, sorry. So IB is equal to 12 divided by j minus 4. And so what is I1j? I1j is equal to minus 2j plus 4 into 12 divided by j minus 4. Okay, so if I divide the whole term by j, okay, if I divide the whole term by j, so I'm going to multiply the whole term by j. I will get like this. So I1 is equal to 2j plus 4 all divided by j minus 4 into j. So what is my I1? I1 is equal to, if I multiply j with this one, I will get minus 2 plus 4j into 12 divided by j minus 4. Okay. So this is your fourth equation, and this is your which one? And this is your fifth equation. Okay. So I'm going to verify this one with previously we have solved like this, right? So here both the current are entering, so I can write this one as J3 into IB. Here I can write as J3 into I1. Okay, so for this one I need to use a mesh analysis, right? So mesh 1. So for the mesh 1, I can write it as 12 is equal to minus J4 into I1 plus J5 into I1 plus J3 into IB. So this I can write it as J I1 plus J3 IB. So this is your first equation, and for the second equation I can write it as J3 for mesh 2. Okay, mesh 2, J3 I1 is equal to minus J6 of IB minus 12 IB. Okay, so I can write so if I divide the whole term by I1, right, whole term by 3, you will get IB, right? So this is J2 minus 4 into IB JI1. So if I multiply by J on both sides, I will get I1 is equal to J2 minus 4J IB. So what is IB now? IB is equal to I1 divided by 4J. I1 divided by 4J minus 2. Okay. So you can substitute this value in first equation. 12 is equal to minus 2J minus 4 into IB plus J3 into IB. So on solving, we'll get J minus 4 IB, right? So therefore IB is equal to 12 divided by J minus 4. So once you find the value of IB, you substitute in the equation IB is equal to I1 divided by minus 2 plus 4J. So you will get the value of I1. Okay. So I1 is equal to IB into minus 2 plus 4J, right? So you substitute this value. Okay, if you substitute, you can verify that the previous problem value is similar to that of this one.